Hello, welcome to my channel. This is part 4 of the video series. In this video, we see how to use Digitalocean API to manage Droplet instances. We'll primarily do two things. One, use Digitalocean API key and install Paramiko to interact with Cloud Droplet. The second one is install PYEZ, a Juniper Sdk written in Python, which help us back configuration from the VMX Docker that we installed. So when we see VMX on DigitalOcean, right? So we interacted previously with the Droplet through the web browser, right? We can also interact with Python and other interfacing options. We'll stick to Python in this video, but if you're interested, there is a REST API, and the documentation is pretty good for the REST API as well. I'll try to present it in the links or in the description. So for any interaction with a DigitalOcean platform, we need something called an API token, right? So what we'll do next is we'll create an API token. This is probably similar to every other API based interaction, be it DigitalOcean or AWS or any of them. Then we'll try to power on and power off the Droplet, and then as stated before, we'll try to install PYEZ, which is a Python SDK to interact with Juniper devices. So in this case, we'll interact with the Docker image to back up the configuration every time when we power off the instance or like switch off the router, right? So I hope this will illustrate a very simple non-standard scripting, and this will help us to save the cost. So the first thing is we'll search for DigitalOcean API. We should see the Git page. So we'll go to the Git page. So this is the Git page, and we'll navigate to the bottom of the page, and we can see how API can be used to interact with DigitalOcean. Most of the examples are ready made, and I have not done anything extra, just picked up some of these and illustrated with this. So that's a very straight example on how we can power on and power off the device, right? So the importance of API comes in if you wanted to experiment. It would be nice to have the script to start the Droplet, load the config, start the Docker. The VMX Docker in itself would take 10 minutes to load, right? So you could script something like once you switch on the provider, like spin up the Docker image, and then once it's done, like send a message, right? So I used PyCharm. PyCharm is really nice, but I saw people using Visual Studio. Even that is pretty nice. So we'll first generate the API key before starting to write the script. So we'll go to DigitalOcean. So under the API section, we can give any arbitrary name and copy the generated API key. So it has both read and write. So once we copy it, we'll create a sample script, right? The easiest way to verify any package. So if you go to the GitHub page, the first thing that they'll probably do is ask you to install the package. So I already have the package installed, as you can see. The easiest way to check this is you can import the DigitalOcean, and it should not throw you any error. And if I try to do a dir of DigitalOcean, you'd probably see the various methods that help us to interact with it. So a base API, probably a manager which manages the session token, or it could be the Droplet itself, so where we'll use Droplet power on and power off. So the examples are pretty straightforward, and it should be easier to script it out. So once you have a grip of this, we'll import DigitalOcean. So we have verified the DigitalOcean package exists on the Python repo. right? So manager is an object where it is the main object which will tries to like manage the session. So we'll refer this manager, use the API key, and all of this is there in the Droplet. So we'll use Digitalocean, we'll call the Digitalocean, and then we'll call the manager, and this is the API token which will identify the account, and then it will try to get resources from the account based on what you want to do. So once we create the manager, it's now easy to use various built-in functions. Now the advantage of the editor is it will like help you to understand what are different methods that you can actually call on this particular manager function. So I'm importing time here. We'll see like why I imported time. There is also an import of PDB. PDB is Python debugger. It's not really necessary in this case. I use PDB to stop the program execution flow and get the variables. If there is a chance, we'll illustrate it, but it's not necessary. So you can see like there are many options, many functions on particular manager. For this example, we wanted to like just get the droplets associated with the account. So that's how simple it is. Now it went in, it fetched the number of droplets which are there on the system. It's very important to notice the way it lists out the droplets, so you can clearly see it's a list. This particular the usage of list will come in handy when we go on to the power on and power off section. So little details like this will help us to understand those who are especially new to the programming, like what method can be applied on what, right? So if it's a list, right, then probably you cannot have a power on function directly on the list. You have to actually go through a loop. That's exactly what has happened, right? So that's what we are going to do. So for each element in the list, what I'm going to do is like get the status, then I would say power it on, sleep for 5 seconds, like hold the program for 5 seconds, and then get the status. This is just to give the platform the time to react before it starts reporting us the status. Sometimes you have to give it more to know the status. There is a much efficient way of doing this. I'm just illustrating a very simple non-standard script for anyone to get started. This is how easy it could be. So once we create the manager, right, we used various built-in functions. Now this is the power on script. It is exactly how we would create the power off as well, right? Just copy it, create a new program or a script, and change the function from power underscore on to power underscore off. There you go. You have like the power off script as well. So it's as easy as to copy the same script and edit power on with the power off, and that script can now be used to power off the droplet. This will help you to plan and reduce building with a simple cron job, and it's easier to operate droplet, right? As we can verify, droplet is powered off, and same is the case with the power on as well, right? We can verify this practically. So if I try to trigger on this particular power off script, so we'll verify this, and so that's the thing. So we need to give platform some time to react. So in this case, I've increased the timer from 5 to 10 seconds, and it clearly like shows that the platform status, like the droplet status, is off. We can go to the web browser and we can verify it. We'll also do the same thing with powering on the device. So let's see the droplet status. Let me grab the window. So here is the window. It is like powered off. We can clearly see it. Now let's try to run our power on program and see how it reacts. So the current status is off, and we power it on and grab another status. Again, like we need to give probably I should have given 5 more seconds for platform to react and give us the appropriate status. So if I just refresh the page, right, we can see that the droplet is active. So this sort of small script, when automated, becomes so powerful in understanding the billing, understanding the ease, and also like if you can code in more with the way to send a message to one of your favorite apps or send a message directly, then you are in charge of your personal billing. So the next thing is now we have understood the power on and power off, right? Now we'll try to install PYEZ. So first I'll verify if pip3 is there on the system. So this is not on your laptop, but this is on the droplet itself, right? So we will use PYEZ on the droplet to interact with the Docker. So a simple search for Juniper Python Sdk or installing Juniper PYEZ would give you the Juniper's official page. So let's navigate to the official page. So this is the Python based SDK to manage Juniper network devices. Most of the examples I have followed are from this official documentation. So I have like picked up a very basic example and even like dumbed it down to illustrate how easy it can be to write a script. And in the next video, like we'll have more detailed approach on what the script does. But for this video, like this is how you would install it, this is how you would think about the script, and I would like to show like how you interact with the actual script itself. We can actually like install PYEZ on a Docker without having to install on the base system. This is a lab system, so it like really doesn't matter, right? In a production system, probably it's better off you install it on a Docker and then use a proper vault system which manages the passwords. Now it's exactly the same. You would use a REPL and verify it. What I'm trying to do now is install Parameco. So we'll use Parameco. Parameco is simply a Python class or a Python method where you can use SSH commands to interact with the Linux server in this case, right? So when we start the droplet, we will need certain number of commands to start the droplet in this case. Yeah, I'm sorry. So we'll first try to connect to the Linux server hosted on the platform, right? So we'll pass few commands and start the Docker. This will be the building block when we start the droplet. It will auto start the Docker, creating it afresh. Remember, VRNET lab does not store configuration, right? Hence, we need to backup whenever we are powering off the droplet, and then we need to like delete the Docker and spin up a fresh Docker from the image which we already created and load the last saved configuration. Now the hierarchy is pretty much the same. So you will always have a username, you will always have a password, a port, and then the list of commands for Parameco, right? So and which host you would like to connect to. So and as long as you have a list, you'll probably loop through it. So we'll try to loop through it, and then we'll collect the output, and then we'll present the output in a readable fashion. So it started the Docker. As you can see, the script has already started the Docker. Now Parameco has few methods. One is SSH client, which will actually help you to SSH into the device, and then there is a auto add policy, right? As you can see here, it helps to like maintain and automatically add the SSH keys. So in this case, these are like standard set of interaction with Parameco. I'm just like fast forwarding it. I'll make sure that the script is available, but the entire idea is like probably you can go through it and you can make a simple script on your own. It's not even like 40 lines. So yeah, so we have the Docker ready. As you can see that there were no errors and it started spinning up the Docker. This is how easy it is to power on the system and then delete an older Docker image and then like spin a new Docker image right from the scratch, and you can do this pretty much every single time you want to power it on, and then every single time you want to power it off, right? The last thing that I would like to do is like illustrate the PYEZ version, where it does many things. In this case, we'll use PYEZ for configuration backup, right? This is the main logic. So the logic here is to retrieve this particular config, the config which is on the device, every single time we power off the instance. And just before powering off the Droplet, we'll take the configuration snapshot and we'll save it into the local directory, so that when there is a power on script which runs, right? So what we would like to do is, like, instead of sourcing the default config that VRNET lab uses in its home directory, we'll try to source the last known best configuration that we already have. So just doing a Docker inspect, we'll know like what's the IP. The easiest and the fastest way to check if you have the supported modules is to import jnpr.junus and try to import the device, and if it's successful, then you have the package. So I'll try to like spin up a very small script. The script is already there on the official documentation. As I've said, like, I just trimmed it down and dumbed it down as well to ease it, right? So that anyone who is learning first, they'll like not be overwhelmed with the coding and stuff. So always treat like you need some modules to interact with the device, so you import them and then you build your own logic, whether you want to use a loop to just go through and go through systematically one by one, or you want to like read something or write something to the file. That's all there to it. So in this case, we supply what's there in the device: a username, password, IP, and a port, right? Now then we interact with the device with Juniper provides a config.util, so we use that class, and then like we go in and we interact with the device, get the config, and then we save it to the file. As you can see, it's pretty clear. So once you build the train of logic, then going back and writing a script on it becomes very easy. So the file is actually saved on the system. Now, as you can see, that there is a txt file, and these are the lines of code, like 7 or 8 lines of code, and again, like few of them are the modules. The first and last line, whenever XML generates it sort of generates its own thing. So you can use a sed or an awk to automatically delete the first 2 lines of code and then like have the configuration, everything in the set format. That's the beauty of it. So that's all. Like, we can see the config coming back up. Additionally, what I have observed is like you need to remove it, the first and last lines. There are other great examples as well in this particular web page. You can like pick anything and like try it and try to learn more about how you would implement PYEZ for your own use case, right? So this completes the video. So this was the last part. There will be another part where I just like go through the video and go through the script in detail if anyone else is interested. So this was fun, and thanks for watching. Bye.